Okay, so we're skipping ahead to 3.6 because in 3.6 we will take higher order derivatives, which means we'll take a second derivative or a third derivative or a fourth derivative, which just means taking the derivative more times. Okay. However, for implicit differentiation, I wanted to go ahead and do this here while we're on implicit differentiation. We will take like higher order derivatives with just regular functions and with implicit functions. So I wanted to go ahead and do the implicit part here. So I've pulled this part of the notes up to this section. So our notation that we use for a first derivative, when we're talking about implicit differentiation, is dy dx. You could also use y prime. I don't like that notation, particularly when we get to related rates, so I generally don't use it very much, but it is acceptable there. And then if it was a function, you'd call it f prime of x. There, but these are not functions, so we won't use that here. If we take the second derivative, here's the notation. It's crazy looking. D squared y over dx squared. It seems silly that they have like the squares in different places. But if you think about that notation we use to take a derivative, what's going to happen is you will already have the derivative, dy dx, and you'll be taking the derivative, which we use d over dx to show that we're taking the derivative of that. So if you look at that, there's two d's there, d squared, in the bottom. Really, technically, you need like parentheses around that, but they decide, I mean, it's just notation. It's not so much that you're actually doing that with it. So they didn't put parentheses around the full dx, but it would be like dx squared there. So that kind of helps me remember where the squares are supposed to go. It's usually going to be in the problem, so you will know. There, but this is our second derivative notation. You could use y double prime, where you got two little tick marks behind it, and when we get to functions, we'll do like f double prime. We'll put two little tick marks there, but that'll come a little bit later. So this is just our notation that we're going to use. So the type of problem we're going to see is just going to ask us to find the second derivative for some sort of function, and we are going to have to give our answer in terms of x and y. And what that means when it says give your answer in terms of x and y, it means no dy dx in your answer. And we'll see sort of as we go along what that's going to look like. So in order to take the second derivative, you have to take the first derivative. So these problems are automatically twice as long because you've got to take the first derivative like you guys were already doing and then take a derivative again, right? So they're already longer. Let's start with first derivative here. So to take that first derivative, this is the process we've already been through. This one's not too bad because it doesn't require any special rules. We're just going to have 2x plus the derivative of y would just be 1, but it would have a dy dx with it, and then we'll get plus 6y dy dx equals 0. Once we take the derivative, we want to move all of the dy dx stuff to one side, everything without a dy dx to the other. I'm going to go ahead and factor. It might be helpful to you to remember there is a 1 there. So when you factor out dy dx, you'll have 1 plus 6y, and then you'll move the 2x over to the other side, and it will become negative. And then you'll just divide by that 1 plus 6y. So the first thing that will be important is for you to get your first derivative right. Because if you get your first derivative wrong, then your second derivative is definitely going to be wrong because you're starting from... These usually either, if they are on an FRQ, they will ask you, like, it'll be a part A where you had to find the first derivative, and so they'll grade with you if you have the incorrect first derivative. Unless, like, let's say your first derivative is supposed to be negative 2x over 1 plus 6y, but you got 2x plus 3 or something super simple. They won't grade with you if the problem has been trivialized, like it's been made too easy, because the derivative of 2x plus 3 is 2. So, like, you would have this correct second derivative, but it wouldn't be even close to what you were supposed to be doing. So, as long as you're, like, in the ballpark of difficulty, they'll grade with you for that. A lot of times, these will show up on multiple choice, or they'll already give you the first derivative, so you're just taking the second derivative. You'll see whenever we get all the way through, especially one of these later ones, like, they're not going to ask you to do this start to finish on the actual exam very often because it takes a long time to do. So we need to know the process start to finish, just so, like, we're able to do it if asked. But sometimes, like, maybe they go ahead and give you the first derivative. So you don't have to find the first derivative, you just have to find the second for that. That's, like, something they may do. You do not. So in the second part, well, there's going to be one, like, little thing at the end. In the second part, we are going to take what we've got here, and we're going to take the derivative of both sides. This is going to require a quotient rule, or if you would rather, you can make it a chain rule by using some negative exponents there. I think, since there's different variables, I think I'd just stick with quotient rule here, although you're welcome to do it the other way if you prefer. So if I take the derivative, like what you're doing now is we're taking the derivative of both sides so that I can get my second derivative. So on that left side, I just get the second derivative, d squared y over dx squared, right? That, the derivative of dy dx is the second derivative. On the right-hand side, I've got to take the derivative using the quotient rule here. So that's going to be low, which is 1 plus 6y, d high. So derivative of negative 2x is negative 2, plus high, so the high is negative 2x. You're right, it is. I don't know why I said plus. It will turn to a plus, even though that's not what I was thinking. I was not that step ahead. So high, derivative of the low. Now here, what is the derivative of 1 plus 6y? It is 6 dy dx over low squared. Okay, so the thing that makes this part difficult is we just found the derivative of a y, so we had to put dy dx. And the answer says that, or the question says I have to have this in terms of x and y, meaning I cannot leave dy dx in my answer. So that is going to mean that I have to replace dy dx. I'm going to clean this up a little bit first before I try to put that in there. So I'm going to go ahead and distribute that negative 2 and multiply this stuff right here together. So I'll get negative 2 minus 12y plus 12x dy dx over 1 plus 6y squared. Now, I can't leave dy dx in my answer. This right here, oh wait, I didn't mean to, hold on. I didn't mean to highlight that whole thing. This dy dx right here cannot stay. What is dy dx equal to? The derivative of the y, specifically over here, I got dy dx. This stuff is dy dx, right? We're groaning because what is this going to be? We're going to substitute this in, and it's going to create a fraction inside of a fraction, right? Oh. We can do it. We got a can-do attitude. Can-do attitude right here. We can do it. We got negative 2 minus 12y plus 12x times negative 2x over 1 plus 6y over 1 plus 6y squared. Now the good news is on a free response question you could stop here because you don't have to simplify. It's okay to leave a complex fraction. So on a free response question we could quit here. A lot of times on a free response question, you'll have to like plug in a number or something like to get the value of the second derivative at that point. That would not be that bad because if you put numbers in here, you could simplify that more easily than if it had letters. So I would plug all the numbers in and then figure it out if I needed to here. But in the event that it is a calculator, in the event that it is a like calculator inactive problem where we have multiple choice, they're not going to leave it like this. They're going to simplify. So I want us practicing this here. So since this is a fraction, it's probably a good idea to like put this over 1 right here. And we could put that stuff together. So I've got negative 2 minus 12y minus 24x squared over 1 plus 6y. And I don't have the answer for this one here with me, but I am certain that whatever the answer is going to like have 1 plus 6y to the third in the bottom of it. And it looks like it'd be like really nice to just like move that down to the bottom right here, but can I do that? Not right now because 1 plus 6y does not go with every term. So we could get common denominators. We can do it. We can do it. All right. So common denominator needs to be 1 plus 6y. So that means you got to multiply by 1 plus 6y on the top and bottom of both of these fractions here. So we will get this negative 2 will get distributed here to 1 plus 6y. So we'll get negative 2 minus 12y. And then on the next term, negative 12y will get distributed. So we'll have minus 12y minus 72? 72? Yeah, 72. Y squared. And then you don't have to do anything to that last one because it already has a denominator of 1 plus 6y. Okay. We're really close. It looks worse than ever, but we're really close. What should we do now? Okay, this bottom I could make it a fraction. Dividing fractions, easy as pie, flip the second and multiply. So that'll look like this. While I do that, I'm going to go ahead and put some stuff together in that numerator. So I'll have negative 2 minus 24y minus, good gracious, 96. No, I can't put those together because one is a y squared and one is an x squared. So minus 72y squared minus 24x squared over 1 plus 6y. And if you skip this and do that part in your head, you know, that's okay. Because those will just combine and we'll get all of this. They might factor out a negative 2. I think I will. 1 plus 12y plus 36y squared plus 12x squared all over 1 plus 6y cubed there. And I don't think there's anything you could do with that numerator. Definitely not that would cancel out with the bottom, so you would just stop here. And there is your second derivative. It is the same process we've been going through. It's just longer because they're basically asking you to do it twice. And that second time is probably going to be more difficult because you probably end up with a fraction over here. So you probably have quotient rule on the second. So they're kind of bad. Your assignment will not have many problems on it because they're kind of bad. But we can do it. All right, let's see. Let's see. We kind of need to do both of these. We kind of need them both. Hopefully we'll have time to do that third one. All right. For the next one, second derivative, before you can find second derivative, you must find the first derivative. So we've got, right here, 3xy. What do I have to use to take the derivative of that? That is a product rule. It is so easy to overlook that because it's tiny. But product rule has to happen here with the 3x times the y. So you'll have 3x times the derivative of y, which is dy dx, plus y times the derivative of 3x, which is 3, there. So that takes care of our 3xy. We still have a 2x squared, so that will be 4x. And we've got a 10y, so that's just 10 dy dx. So we need to move everything with a dy dx to one side, everything without it to the other. I think the other day whenever we looked at Marley's problem, I think I would actually move the dy dx's to the right side this time, just because I end up with a lot of negatives if I move it the other way, although it does not matter. When you're doing the product rule right here, you've got 3x times the derivative of y, which is your dy dx, plus you got to do y times the derivative of the 3x. And so the derivative of 3x would be where that 3 comes in, right there. Yeah, so this part right here, like this whole thing, is this part. You got to do the product rule for that. Okay, I think I'll move my dy dx's over here. So I got 3y plus 4x equals dy dx times 10 minus 3x. And then I just need to divide. So dy dx would equal 3y plus 4x over 10 minus 3x. It would be fine to have basically the opposite signs of all these, negative 3y minus 4x over negative 10 plus 3x, like that would be fine. But because we got to take the derivative again, the fewer negatives you can have, the better. Like, so if you have lots of negatives, you could like just multiply through top and bottom by -1, and that would reduce that a little bit of your pain, teensy bit of your pain. So if we take a second derivative, now this is where first derivative, hopefully by this point you're like, oh yeah, first derivative is not that bad. We're good here. Second derivative is going to have a quotient rule, or a chain with a negative exponent if you want. Neither one are easy. I don't think it makes it much easier to make this chain here. So let's just do like we did on the last one. So d squared y over dx squared is going to equal low. So 10 minus 3x, make sure you're putting parentheses around everything here, times the derivative of the high. You got to have parentheses here because you're going to have two terms. So derivative of 3y is 3 dy dx. Almost always, because usually whenever you do the first derivative, you end up with a fraction. If somehow you did not end up with a fraction, then you wouldn't have to do the quotient rule. You might have something else to deal with there, but most of the time you end up with a quotient rule on the second part. And then the derivative of 4x is just 4. So that's low, d high, minus high, so 3y plus 4x, d low, which is just -3, all over low square. I would probably try to simplify this a little bit first. I'd probably go ahead and like distribute here. Oh gosh, so bad. It's so bad. All right, we got 30.
Can you substitute at any point?
Yes, so once you take the derivative, you can substitute at any point. So you have to take, like this step I just did, you have to take that derivative. You can't plug anything else in here. But then, like, after this point, if I wanted to go ahead and put dy dx in right now, I could.
Will that help anything or no?
At what point can you stop a free response?
On free response, we can't stop yet because we haven't plugged the dy dx in. Once you plug the dy dx in, you could stop for that.
Plug it in now, what do you have to do?
On a free response, yes. But we're practicing for the worst case scenario here, and that is multiple choice where we have to do this here. All right, so we got 40. Then we got to do, we'll get minus 9x dy dx. There's two dy dx's. Plus 12x. Gosh. Okay, I'm going to, that's the first part. It is minus, thank you. You guys can see how this can fall apart so quickly. All right, I'm going to do this right here for that second piece. I've got a minus here and a -3. I'm going to make those positive and then distribute this 3 right here because we could move that like 3 up to the front and it would become positive. So we'll get plus 9y plus 12x. Yes. So at least there's some good news there. Yeah, small victory right here. And nothing else that you can put together, is there? No. So let's put dy dx in here. Oh, gosh. Okay, we can do it. Yep. Got our can-do attitude. You're going to need your can-do attitude for these problems. We should. That is a great idea. And we could wear it because it could just say, like, have a can-do attitude and AP Calculus, because, like, if we put math stuff on it, you can't wear it to your AP exam. But if we just put can-do attitude, you could wear it. Yeah. Yeah. Somebody make me a poster. I will put it up for us. Yeah. Oh gosh, we're not going to get to that last problem. There's no way. Are we even going to get done with this one? I don't know. I can't make any promises. And aren't you glad I didn't try to get you to fit this all in a box? Go show your parents this problem. Okay. All right. So, all right. If we're getting common denominators here, so it's important to keep your like terms separate, okay? So this is one term because it gets multiplied together. It already has the 10 minus 3x. It's okay. The 40 does not have, it's a separate term. It does not have the 10 minus 3x. So we need a 10 minus 3x here and a 10 minus 3x here. The 9x goes with the other stuff here. It already has the 10 minus 3x in the bottom. It's good. This has not got 10 minus 3x, so we're going to put this here. Okay. So we're going to put the equal sign over here to give us extra room. Once we multiply, we'll be able to cancel some. Okay, we might be able to. Yeah. All right, so we're just distributing here. This 30 gets distributed. So we'll have 90y plus 120x. My 40 gets distributed. So 400, this is fun, isn't it? Okay, minus 120. Oh, look, though, that felt good. I got a positive and a negative of 120x. All right, make sure when you distribute this 9x here, it has a minus in front of it. So minus 27xy minus 36x squared. Okay, we're almost there. Multiply by 9y, so we got plus 90y minus, no, it does combine, 27xy, but it doesn't cancel. Right there, okay. Whew. All right, that's all over 10 minus 3x. Is it okay with you guys if I do this? Because there's so much to write here. Like, if I go ahead and make this a fraction right here, is it okay if I go ahead and flip and multiply? So that we don't have to rewrite that whole numerator again? The TI-89 will take this derivative so I can check if it's right, but I'm not even putting it in when we get done with this. If I've messed up, I don't want to know. All right. I got 120x and negative 120x. Those cancel. I do have a few things I can put together. I can't cancel them, but I can put them together. I got this 90y and the 90y. So that's 180y. I've got the negative 27xy and the negative 27xy. So that's negative 54xy minus 36x squared plus 400 over 10 minus 3x cubed. And other than, you can definitely factor something out of that numerator because they're all even numbers. You can't really do anything. It's not going to cancel with anything in the bottom, so I'm not going to worry about that step. I'm just going to leave it and be proud of myself here. And I'm not even going to check the answer to see. There. We did not get to 3. It's one where you plug in a number. I am going to adjust this and just find you a couple of good problems for you to work out with a good can-do attitude here. I'm not going to make you do that many because, as you can see, this takes forever. Let's see.
If we get to a point where we just like are not getting the answer, is it okay? Like, you know what I mean? Like,
Just do the best you can. Yeah, do the best you can. Let's do. I'm gonna give you one. It's from 180. I'm going to give you one that should be easier. So 51 should not be terrible because it will not require any special rules at all. And let's do 52. So 51 and 52. 51 should be, like, I feel like we should all be able to get to the answer. I'm going to, on purpose, I'm not going to give you the answer to 52. So that you have to just do it. Try to get rid of any complex fractions. You know they're not going to let you leave complex fractions. And then we'll just see what we got on Monday. I'm not giving you the answer. It'll be better that way because you can't check it. So you can't, like, you can't go, you know, spend 12 hours. This is a homework assignment. Yeah. So, yeah, do those 2 for me over the weekend. On FRQ, these are the ones you cannot do. So you should be able to do everything else, or at least we've learned what you need for those. Yes, that'll be fine.